So good afternoon, everyone. For some reason, I always find myself giving the presentation on cryptography after lunch. Lucky me. But as you're probably aware, that since you're here, key management and cryptography is obviously critical to the cause that everyone traveled into Phoenix around the Hyperledger initiatives. So thanks for being here, especially in the light of issues with coronavirus. My name's Alex Rabke. I'm a director at a company called Unbound Tech. We are a cryptography company, and specifically a type of cryptography known as MPC, or multi-party computation. I titled the topic of my slide as Block to Basics, right? Play on back to basics. And I want to just take a quick poll of everyone in the room on a scale of 1 to 3. 1 being don't really know much about key management, came here to get the 101. 2 is you're a technology or security practitioner, and 3 is you're a cryptographer. So 1's in the room, people just learning about this. 2's and 3's. 1, 2, 3. All right, please don't play Stump the Chump. I'm not a cryptographer, but I'll do my best. Open it up to Q&A at the end of the session. So let's jump in. Oh, how far we've come in the past 11 years. What is internet to everyone gets a blockchain. So it's really exciting to see this ecosystem of private chains develop, and specifically the progress that's been made with Hyperledger and various participating companies, of which Unbound is one, naturally while we're here. The reason that I think it's important to call attention to the fact that there's been historically a level of hype around blockchain and innovation technologies in general, and where we are today, because we're delivering production use cases to the market that are adding business and technical value. And many of you are involved in these types of projects and would love to connect with you each and learn more about what's going on. I'll share some of the things that we're working on. But the point being is that fundamentally, blockchain is a technology that has an underlying reliance on cryptography. And there's a lot of potential for blockchain-based technology and the applications of it, but there's also inherent challenges in the technology. So first of all, blockchain isn't a panacea to our technology plights that exist. There's certainly advantages and disadvantages. And one of those, and those disadvantages and advantages need to be considered in terms of the use cases we target. That being said, when the technology is a fit, it tends to be a really good fit. But it does present us with a historical trade-off or compromise between what's referred to as the trilemma. Anyone in the room familiar with this notion? Right, it's the idea of having your cake and eating it too. So when implementing a blockchain technology like something based on the Hyperledger fabric, how can we implement technology in a way that delivers security, scale, and decentralization to capitalize on the best attributes across those elements? So when we talk about the domain from a pillar-based standpoint around security, again, back to the idea of key management and cryptography being fundamental to the success of this technology, we have to understand, and the market needs to understand, and I do believe there's a lot of growing awareness around this, that we're ultimately protecting and storing data on a distributed ledger or database, and if you don't control the keys, the private keys to that database or that ledger, it's not your data. This applies to public-based use cases like cryptocurrencies and private use cases in the enterprise around initiatives we worked on supply chain and other various types of implementations. One of the stories I like to tell is the notion of digital transaction signing. This takes place in the enterprise space with instances like software code signing, for example. In the context of this situation, it relates to how transactions are signed and hashed to the blockchain. So when you go to a store and you swipe your credit card and get a receipt and sign it with a smiley face, who's checking to make sure that you actually signed the receipt accurately? Who's verifying that the signature was accurate and reliable and authentic? This ties back to the identity of the participating parties, and it's only as sound as the verification that occurs, and this verification can and should happen at the cryptographic layer. So the security element is critically important because the foundation of the technology relies on this. Now, security and its relationship with information security historically has led to a compromise between scale and usability of the technologies that are being implemented. So delivering secure solutions at scale can be challenged, challenging. And specifically in this space around the technology that we're dealing with, transaction-based requirements can be high in some instances, or have a requisite degree of accuracy. And in consideration of scale, deploying not just the node infrastructure behind the blockchain technology itself, but actually the operational infrastructure in and around that must accommodate enterprise and global-based use cases. A lot of the companies in the showroom upstairs and who are represented by speakers today represent huge multinational and global organizations. And many of the implications of blockchain technology and the positive impact it can have is based on an ability to collaborate around data that is globally distributed, which brings us to the notion of decentralization. And I speak often on the topic of crypto hygiene and what good encryption and cryptographic practices in the enterprise encompass. And I tie this back to technology frameworks that are well known and understood, because ultimately we're delivering a new paradigm to the market with technology that's bleeding edge, not bleeding out. And in order to relate that back to key stakeholders who we need to gather buy-in from and resources from, whether it be human capital or financial investment, we need to articulate things in a way that are well understood and accepted and have a legacy of successful implementations. So for this, I often reference the NIST 800 series, which if we have any cybersecurity practitioners in the room might be familiar with. It's actually a really good set and library of resources for implementing information security controls across the enterprise, and many of them tie directly back to encryption and cryptography, which of course, as I mentioned and will continue to mention, is the underpinning of everything that we're doing, whether some people realize it or not. And there's a framework. I got this thing with triangles, obviously, right? It's the trilemma and then the CIA triumvirate. So delivering a decentralized model that's aligned with a well-understood InfoSec framework that encompasses confidentiality, integrity, and availability of the digital services being provided is one that in a lot of times is aspirational, but it doesn't have to be, nor should it be. So ultimately, I'm drawing an emphasis on why key management is critical, and it's again because the technology relies on an underpinning of encryption and cryptography, but ultimately it comes back to the fact that crypto is hard, right? There's a reason only 2 or 3 of us in the room consider themselves in the field of cryptography, and it's because it's a really challenging field of study and an even more challenging field of implementation. So the question is, how is this being handled today, and how can it and should it be handled in the future? So I'll step you through exactly what some of the common adoption models look like, what my company is doing in the space. I'll show you a quick demo of what our solution looks like, and then we'll wrap up with some Q&A. The most accepted paradigm in the space is really this notion of protecting keys. And typically this is done with something called a hardware security module, or HSM, which is a black box. Typically it's a piece of hardware that sits in a data center, either yours or someone else's, and it exists with the sole intention of protecting cryptographic keys and certificates. That's the only reason it exists. No one buys an HSM because they want to, right? It's supposed to be an enabler. I see some smiles in the back of the room. It's supposed to be an enabler of technical service delivery. And in some cases, it's quite good at that, specifically around the notion of key protection. But what's unique about the blockchain space is that we're not just concerned with key protection, but we're also concerned with key usage, and specifically the notion of fraudulent key usage. This can oftentimes come from not just external, but also internal bad actors, or simply the mismanagement of keys where they're not necessarily stolen, but they're simply lost or mismanaged or made unavailable. In instances or use cases where high availability is a requirement, this can become challenging when you rely on a hardware-based model. The ultimate emphasis here is that we live in a digital era, and we need technology solutions underpinnings that are suited for digital service delivery. And it's my belief and my company's firm belief that the hardware model is one that does have its place in the market, but is becoming more antiquated by the day, and in many instances does not actually enable the innovation that business and technical leaders are striving for today. a very quick and dirty summary of where and how the key landscape comes into play in the context specifically of Hyperledger Fabric related projects is summarized here. And again, I'll keep it really high level because there's whole layers of certificate procurement and how this type of stuff works. But essentially, client applications allow users to create transaction proposals, and these through a wallet-based implementation, which is protected by private keys. Through a software development kit, there's digital communications that generate proposals to the Hyperledger network. And one of the things that's interesting to me, and I think an advantage to the network, is this notion of peer-based endorsement to review and quote-unquote endorse transaction proposals so that they're actually posted to the ledger. So I think it's one of the elements that makes the blockchain architecture for Hyperledger somewhat unique and potentially powerful. So keys are involved on a daily and even in certain use cases a per hour, per minute, or per second based workflow requirement. I'm seeing a quick formatting issue that I want to correct because I meant to create some suspense with this next slide. Okay, so everyone close your eyes. Essentially, these black boxes are used to protect keys, and they're primarily concerned with, again, the protection of the keys, but not so much the usage or the fraudulent usage of them. Again, I've emphasized that this tends to be, in many instances, a model that's quote-unquote secure. I never say, coming from the cyberspace, that anything is 100% secure. If anyone tries to sell you something that's 100% of anything, they're 100% full of it. I've used that line before, and it becomes interesting because I'll talk a little bit about the operational model around traditional key store and key management based architectures and implementations. But from a pure security standpoint, again, I've said this probably 3 or 4 times, the sole purpose, or reason of being for the HSM-based technology is to protect keys. So why is it that when you pay attention to the space, there's many, many instances, not just in research, but also in the field of either key extractability done in a way that it's not supposed to be done, or fraudulent key usage? This is the FUD slide. And the one that's worth looking into in your free time is some research done by the Ledger team that was posted at Black Hat this summer. Scary thing here is that they were actually able to demonstrate remote access, again, to devices that are supposed to be physically tamper-proof. They were able to demonstrate remote access to exfiltrate the key material and then apply it in a way that was not detected by the device, that is intended purely to protect and alert if there was some type of tampering done to the device. So again, it's not an ideal model in many cases. This being a demo-based presentation, I won't go into detail on the numerous alternative models. I will focus on what our companies delivered to market about five years ago with organizations that truly deliver services at enterprise scale and do so in a way with quite rigorous security and operational requirements. Namely some of the large financial institutions like Citibank and Goldman Sachs. The yellow circle that's represented here is, quite frankly, a poor illustration of how our underlying technology is taking a private key material and sharding it or distributing it during the entirety of the key life cycle. So this is a little bit of, it's not a little bit, it's a hard concept to grasp if this is the first time hearing about it. But the initial intention of our technology, MPC, was used for use cases like auctioneering, where multiple parties could collaborate around data, specifically compute around data, so that they could provide an input with the identity of the input being private and the input itself remaining private as well, but the output becoming publicly verified. So we've applied this technology to key security and key management such that blockchain private keys never exist in complete form ever during their life cycle. We call this mathemagic, but it's actually backed by proof of security in the field of MPC research. Many people, including myself, are learning about this technology in just the recent years or potentially recent months or potentially today. But it's actually a field of cryptography that's been in study since about the days of disco. So the early 80s was when the research into MPC began. It's known as a zero-knowledge proof. And it really was not brought to market at commercial scale for a number of reasons. I won't go into detail, but it relates primarily back to performance challenges and the dependency of the protocols. What, of course, is different about Unbound is that starting 5 years ago, we developed some protocols that are patented and deliver reliable, enterprise-grade, scalable key security and key management based on MPC protocols. So we're achieving a degree of security that some of our clients claim is even more robust than a hardware-based model because the key material never exists as a single point of failure. But more importantly, we're delivering a software-defined value proposition. So if anyone in the room is familiar with the company VMware, right, they're most notable for virtualizing server-based infrastructure. I don't think there's a company in the world who's not happy about virtualizing their infrastructure. And while it was a foreign concept at first, and there were certainly growing pains around it, it's really what's enabled the next generation of Web 2.0 and now Web 3.0. So you can kind of think of this as a software-defined cryptography scheme that is delivering security guarantees at a software-based value proposition. A further emphasis, again, because I get the question of people who kind of liken our technology to other cryptographic schemes for the 2s and 3s in the room, namely multi-signature or triple S, Shamir's secret sharing, say that 3 times fast, based schemes. But with any alternative solution in the market, key material is brought together at some point during its life cycle, perhaps at generation, store, use on the wire, whatever it might be, so that the private keys exist as a single point of failure. There's also a number of integration and operational concerns with some of the alternative availabilities in the market. And I'm emphasizing, once again, I'm glad to see some people taking pictures here, that the key material never exists in complete form. Okay, before going into the demo, this slide is intended to look much like the trilemma talk track I spoke to prior, but I want to emphasize now on some of the specifics that I've covered in the last couple minutes, going from, hey, never heard of this, to, okay, now we have some familiarity. Real quick before jumping in, any comments or questions? I could take 1 or 2 before going on.
So the key never exists in a single form at rest, but when it's used by the actual cryptographic algorithm, it has to be combined with the shards that you have. Right?
It doesn't have to be combined with the protocols behind secure multi-party computation, and this is a foreign concept. I never like to use the words trust me, because when someone tells me that, it scares me. But what we've done and do on a frequent basis with clients is run them through the protocols and the mathematics behind this. There's thousands of scholarly papers and research citations and things of this nature. And our founder, Professor Yuta Lindell, he's the big daddy of MPC. He literally wrote the book called Modern Applied Cryptography.
So your key material is split somehow, and what happens when you lose parts of the key or some of the servers or something? Is there some, or like more than one, is there a sufficient redundancy or duplication to guard against that?
Yeah, it's a really good question. I won't go into the detail right now because we don't have time for it, but essentially it's the notion of backup, availability, and recovery, and there's mechanisms for all that. Yeah, because it's an operational concern. One more and then I got to move on.
Can you apply this to signing transactions in Hyperledger fabric?
Oh yeah, I'm going to show you.
Okay. How exactly do you sign a transaction? Have you created a separate cryptography provider?
I'll show you that also. Yep. Okay. If you're not too technical, don't get scared by the architecture. This is actually based on an anonymized use case with a client that we're delivering a Hyperledger-based blockchain use case with. And the use case is around, I can't say the company, but the use case is around essentially tokenizing assets and doing partial asset ownership for high-value physical assets and tying that ownership record and verification back to Hyperledger fabric, okay? So where it says blockchain application, that would be any type of user-facing application that a service provider or technology provider is offering to the market based upon Hyperledger fabric. But again, that blockchain application is something that would most likely look pretty through a user interface or something like that. In my demonstration, I'll be using an application called Postman. So think of that as the interface for the user who's going in to the Postman application and signing a transaction for a high-value asset, okay? That application will communicate to our system, what's known as the Unbound key control. This is the key security and key management mechanism based on MPC for the blockchain private keys. And encryption, decryption, signing processes occurs within that software perimeter, secured again by that MPC paradigm. And then transactions are reported via the application service provider to the Hyperledger node. The data is hashed to the node that way, okay? So I'm going to show you what it looks like. All right, so three things. Architecture. This is our Unbound key control web user interface. There's also an API in which the automation elements and things take place. And then I'm using the Postman application as a sample application. This would be much prettier. This would be from your service provider that's offering the services to market. So in the Unbound user face, we have a number of features. Clients can be added in the UI through the click of a button. They can be named here, activated through various security schemes, multi-factor authorization and authentication, these types of elements. I've added a Hyperledger client, which is my device. It's validated by a CA delivery of a certificate. And I'm provisioned as a user in the system, security officer in the system with standard authentication access. And note that with our system, clients and users are actually cryptographically verified and segmented to the system, and can have roles applied to their usage and permissions. So this is where policy and automation takes place, because users and clients can be permissioned and added to the system in a way that's automated based on some type of a role-based access type of a scheme. I'll just mention it because it says it here. There's secrets. The software can also be used to protect secrets, perform secret protection and management as well. But let's get to the fun stuff around keys. Remember, not your keys, not your data. I've created three keys here that are representative of various cryptographic keys that be used to sign certain transactions. Keys are created this way, named and described in the way that you choose. The various types of encryption keys can be chosen, and for the number threes in the room, you might notice some PQC-based schemes, meaning post-quantum. Talk a little bit before we wrap up around the notion of something called crypto agility. And privilege for that key is also specified. So this is an area where we can assign capabilities or restrict them for incremental layers of protection. Again, keys are added with the click of a button. This is an ECC curve that would be used for signing, for example, a Hyperledger-based transaction. The supported operation is a signing operation, and the user ID for the key is represented here. Now let's go back to the Postman application that's used to sign transactions from this service provider for an asset value that'll be posted to the blockchain. I've inserted the user ID and a signing operation into the service provider application. This would be blind to the user, but for the purposes of the demo, I'm showing what it looks like. Let's pray that the demo gods are kind and the Wi-Fi is still connected. This is communicating real time with my demo system, and as you can see, a valid key signature is posted to the application. Now let's jump back briefly to the architecture. So what we just walked through was horizontally from user, blockchain application to the UKC system. What would happen now is that the hash would be posted to the Hyperledger Fabric node and visible in Ledger Explorer. So it worked. I'll applaud myself. I'm sorry? Like key shares? In this instance, 2. Yeah, as you saw in the architecture slide, there was essentially 2 servers. And these are virtual servers. Again, we have no reliance on hardware, which again maps to the ability to deliver digital services, right? Okay, very similar slide, but we went from high level to more complicated to really simple. It's critically important to control keys, and the interesting thing about the software-defined value proposition is allowing key control mechanisms and models that are tuned to the use case. So you can enable the opportunity for your users to control the keys, or you can do it as a service provider. It's flexible from that standpoint. When we talk about scaling to many users, many keys, etc., I was just talking to someone today upstairs who has over 10,000 individual wallets with a private key associated with each of them. Call that key sprawl, because all those keys are stored in a database encrypted by a single encryption key for that database, meaning that if someone accesses that database, whether it be through gaining access to the encryption key or some other side channel based mechanism, they expose all the data associated with that customer's business and the customers themselves. So this becomes really, really scary. How do we take care of key management at scale? It needs to be quote unquote enterprise grade, quote unquote institutional grade, as we think about use cases that occur across broad geographies, broad performance requirements, etc. And of course, in line with the nature and ethos of the technology itself around being a decentralized ledger, but doing so in a way that's secure and compliant. The way that this maps back to what our technology is doing is that notion of cryptographic verification. So we're not trusting application-based and layer 7-based technology. We're actually trusting the mathematical proof of security that I mentioned earlier on. So with all that being said, appreciate everyone coming to check out the session. I hope you learned at least a thing or two, and we'll open up for some questions.
How many shares can I create? When I looked at the Unbound code, the most I could see is I could create 2.
Yeah, in our open source code that you looked at, that's a 2-party MPC scheme. For more than 2 parties, that's part of the commercial software that you'd buy. Yeah, key wrapping is a really relevant use case, because you might have, especially it could be a greenfield or a brownfield deployment, but if you already have a workflow, but do want to protect that single point of failure, the foundation of the security model, then you can wrap a key, export it, import it, whatever you want, but have it be sharded through the MPC-based protocol such that that single point of compromise is eliminated. And happy to talk to you about that use case. Anyone else? Yes?
What about the overhead to use the technology?
Yeah, so historically there's been MPC protocols based on what's known as round trips, and somewhere in the realm of 6 to 12 or sometimes even more, I believe. And what this does is introduce a high degree of latency that must be combated with computational overhead, right? So one of the things that's unique about our protocols is that they're actually 2 round-trip secure MPC-based protocols, and therefore the requirements for implementing this technology are quite low, like single-core processor virtual machines and 2 gigs of RAM per. So there has to be, it's a pair, right? So at least 2 servers that can ride on any bare metal across any cloud or geography. You could Azure East, West, AWS West, Azure East, however it makes sense to architect it, and however many layers of security you'd like to implement. Of course, with the reason you're looking at me that way is performance types of concerns, right? Availability, these types of things. So the answer is that the computational overhead is quite low, and more specifically, for use cases that require high TPS or transactions per second, like a payments-based use case, the performance of our system scales linearly with the number of CPU cores.
Additional question. So according to concerning to the such delay, the which part the component should be applied for this management. Supposedly each node had some sort of redundant components, so the technology does not require. So I thought that should be used for the order in the public architecture.
So you're talking about node redundancy, which would be different. That's a blockchain infrastructure availability. For our system, if you're asking about, you could implement additional clusters of the server pair. Yeah.
I say I'd like to hear your opinion about which node should be used for this technology. Is that
Yeah. So that's like an architecture and design question, and let's chat after this. Any more questions? Yes?
So, yeah, I guess it's just architecture diagram. But in the upfront setup of the application, how do I test the alignment of roles and not consent, but just basic policy, right? The broken policy to the basic things that you guys are sharp.
Right. So if I understand the question correctly, one mechanism for doing that is a method that we have that logs all of the activity that for communications to and from our software boundaries. So there's a logging mechanism through the command line interface that can be exported to some type of automated reporting, like a SIM-based type of solution. But essentially, the verification would be evident through the logging mechanism. If you're talking about validating that from the end user application, the Postman application that I showed, I think it would depend a lot on the application itself. And I either need to understand more about what you're asking, or I might not be equipped to answer that.
Once you write to going to production, right?
Right.
Once you're actually writing to the chain, it's what you.
Oh, I see. Oh, so how do you validate it in the context of the blockchain itself?
Well, in deploying the application, vetting that it's actually that mapping all the application is done correctly.
Oh, I see. Yeah, so it would be a different mechanism based on an application versus a cryptographic versus posting to the node. Let me get you an answer on that. Okay. All right, so just to, am I getting the tap? Okay, so just to wrap things up, again, control the keys, do this at scale, and the one thing I forgot to mention, how silly of me, because who cares about cost, right, is providing a more cost-effective mechanism. Someone gave me a statistic earlier today and stated that of their enterprise blockchain deployments, half of the capital cost is from HSM-based investments. So half of the investment from the market participant is in these black box type of technology. So how do we position cryptography as an enabler of next-gen business services versus an inhibitor and an obstacle of, frankly, a technology and market that's maturing and needs as much help as we can give it. So there's a cost benefit as well that helps to address the scale issue. So remember, the blockchain trilemma: security, scale, decentralization. We're using MPC to do something really novel, super exciting. We have production use cases in market that I can share offline. But thanks everyone for showing up, and have a great rest of your show.